Hi everyone. So today we're going to be talking about dividing polynomials, and this is going to be kind of like a refresh of what we learned back in like an intermediate algebra or even a introductory to algebra course. So I'm going to start off with a very simple problem because I think it's really good if we just like go ahead and dive right into this. So here's an example, and we're just going to divide 131 divided by 3. Okay, so if we use long division, which is what we learned back in grade school, okay, we can go ahead and set this up in our long division format. And then we would say 3 goes into 13 4 times. That gives us 12. Then you subtract 13 and 12. You get 1. Carry down the 1. You get 11. 3 goes into 11 3 times. You would say 9. And then when you subtract 3, you get 2. Now, I know a lot of us, hopefully, doesn't say 43 remainder 2. All right. This is really good if you're teaching division using manipulatives. So you can see, oh, I can create 43 groups of 3 out of 131 objects. It's just I'm going to have 2 left over. The proper way to write this answer is 43 and 2/3. Okay? Because that's really what this is. I mean, if you think about it, if you approach somebody and ask, or better yet, let's say you're on you're at home and you're doing a home renovation project, and somebody asks you to measure a distance, and you said it's 43 remainder 2. What does that even mean? Remainder 2, remainder 2 what? You know, even if you were to get out a calculator. So let me go ahead and try to get out a calculator here so we can see this in action here. So video, there we go. So if you were to take 131 and just divide 3 by it, you would see you get 43.666667, this whole decimal thing. And 2/3, which is really what's left over, is the decimal portion of this, okay? So from here on out, we're going to be using what we call the division algorithm to go ahead and divide polynomials. So recall, all right, that if p of x and d of x are polynomials, with d of x not equal to 0, because you cannot have 0 in your denominator, all right, then there exists unique polynomials called q of x and r of x where, let me scroll up here, where r of x is either 0 or, and this is the most important part, or of degree less than the degree of d of x, such that p of x over d of x will equal q of x plus r of x over d of x. And another way you can write this is if we multiplied everything by d of x, you get p of x equals d of x times q of x plus r of x. Now, what I'm going to write is our problem above, but I'm going to write it in this format right here. We found 131 divided by 3 was 43 and 2/3. Okay? So, first I'll write it over here like this. I'll write this one first so we can see how everything works. So you're going to have 131 over 3 is equal to 43 plus 2 over 3, or 131 equals 3 times 43 plus 2. which is exactly how you would check yourself to make sure you are correct with your division algorithm. Okay? Sorry, I'm having a problem here writing a 3. There we go. Looks so much better. All right, so here's our next example here. Now, instead of doing just a basic numerical problem, what we're going to do is we're actually going to do a problem that deals with polynomials. Okay? So let's see here. Example. Let's divide p of x equals 2x to the second minus 5x minus 7 by d of x equals x minus 2. Now, the thing we have to remember here is this. First, when we divide polynomials, the polynomials have to be in decreasing order. Can't spell today. There we go. Decreasing order of degree. And 2, no missing terms. Okay? So if you look at p of x, we have 2x squared minus 5x minus 7. That decreases in order and there's no missing terms. And the same applies for d of x equals x minus 2. So we're just going to set this up using long division. All right. And then off to the right-hand side, I'm just going to write out my steps of what I'm going to do. If you need a refresher on this, please let me know. And I can post a refresher on how to divide polynomials you're using long division. But step 1, you take the leading terms in p of x and d of x respectively and divide them. You get 2 of x. This 2x becomes the first term in our quotient, and I put it directly above the linear term because it's linear. Step 2, I take 2x, and I'm going to multiply it by d of x, which is out front. So this is going to yield 2x squared minus 4x. I put this in parentheses and just copy it directly underneath and subtraction sign out front. Now I subtract from top to bottom, and that's step 3. So 2x squared minus 2x squared is 0, which is what we want. And then negative 5x minus negative 4x is really negative 5x plus 4x, or just negative x. So negative x goes here. And then we drop down to minus 7. And our entire algorithm repeats. So I'm just going to erase the work on the right. Here we go. I take the first term in my new p of x, which is going to be negative x, and I divide it by the first term in d of x, which is x, and that yields negative 1. So I put minus 1 here. Now I'm going to take negative 1 and multiply it by d of x, which is x minus 2, and that's going to give me negative x plus 2. I put this in parentheses, write it directly underneath, and now I will subtract. So you get negative x minus negative x, which is really negative x plus x, which is 0, what we want. And then finally you get negative x minus a positive 2, which is just negative 7 minus 2, or negative 9. So our final answer would be 2x squared minus 5x minus 7 is equal to 2x minus 1. Actually, let me write it the way they have it. X minus 2 times 2x minus 1 plus negative 9 over x minus 2. So if you look at the definition that we have above, this is p of x. Then the x minus 2 is going to be d of x. 2x minus 1 is our quotient, which is q of x, plus our remainder over d of x. All right? Excuse me. Actually, we don't need the remainder there. My bad. Let me write it like this. There we go. Much better. Much better. Sorry about that. Little mistake. All right. Now, this is how we do long division. The only other technique that I want us to go over is actually my favorite thing to do, which is synthetic division. Now, synthetic division, what it does is it's a very fast or very quick way to divide polynomials when d of x is linear, okay? Which means d of x has to be in the form x minus c, okay? Now, if you remember, x minus c is a factor. C is also a 0 to our polynomial. F of c, or in this case, since we're using p of c, so when you substitute c into the polynomial, you get 0 and all that other stuff. So what we can do here is we can actually take the problem that we just did and synthetically divide it very, very quickly. So let me show you the process and how we do that. First, let me just write out synthetically divide. (2x squared minus 5x minus 7 by, and I think it was x minus 2. Yeah. X minus 2. So the first thing you need to check before you do anything is you got to make sure, and I'm going to highlight it for us, you got to make sure that you have d of x, your denominator, is in the form x minus c. That, we're good to go. Second, you still want to make sure that, and I'm going to scroll up here, that you have decreasing order and no missing terms. All right. Now, when we synthetically divide, I will show you examples where I have to rearrange things in missing terms. But for now, I just wanted to get the method on how to do this. So notice we're good to go. We have no missing terms. It's in descending order. So what I'm going to write is I'm going to set this up as follows. In the upper left-hand corner, all you put is the value of c. So c equals 2 in this situation. You don't worry about the negative sign because we want the form x minus c. Okay? So I'm going to put a 2 right here. Then, in the second box to the right, I'm going to write all the coefficients of each term respectively. So I get 2, -5, and -7. Okay? Now, I will always copy down the very first coefficient. And the process on how I do this is I take 2, the number out front, and I multiply it by 2. So I'm going to multiply 2 times 2, and that equals 4, and I write it directly underneath the -5. Okay? So when you go diagonal, you multiply. When you go up and down, you add. So what I'm going to do here in this second column is I'm going to take -5 plus 4 to give me -1. Okay? Process repeats. So now I'm going to multiply 2 times -1. 2 times -1 is -2. And then I'm going to add straight down that column. -7 plus -2 is -9. Okay? Now, what we just found is this. Those numbers, 2, -1 and -9, the 2 and the -1 represent my quotient, and then the -9 is going to be my remainder. Now, earlier, I made a note and I said, listen, this is unbelievably important that we understand this. So before I write out the answer, I'm going to scroll up so we can see what I was talking about. All right. We got to make sure that whenever we do this, our remainder is of degree less than d of x. Okay? So if you look at d of x, which is going to be highlighted in blue right here for us in the upper right-hand corner of your screen, this is degree 1. Okay? Notice your remainder is degree 0. Now, this also implies that p of x, which is right here all the way up top, so I'm going to label it in red, p of x, that was degree 2. Anytime you divide one time, your degree will always decrease by 1. So, highlighted in blue, our quotient is going to be 2x minus 1 plus our remainder, which is going to be negative 9 over x minus 2, which is the same exact thing as what we got before. Okay? So now what I want to do is I'm going to just do a bunch of problems here, just showing you how to synthetically divide. It's going to go pretty quickly. So if you need to, just pause the video. You can always go back and look at it. But synthetic division is like the most amazing thing ever for mathematicians, because I really hate long division. So I'm so glad somebody figured out synthetic division. So here we go. We're just going to synthetically divide three x to the third minus 12x squared minus 9x plus 1 all over x minus 5. So first, denominator q of x got to be in the form x minus a number. Check. Second, look at the numerator, p of x. I went descending order, no missing terms. Check. So all I'm going to do here is write 5. And then in my next box, write a 3, negative 12, negative 9, 1. Copy down the 3. And on the far right side, you can always put this little box if you want to, and you can always label it remainder, because that's what it's going to be. Since this was a degree of 3, since when we started, 3x to the third, I already know my answer. Oops, sorry. I don't know how that happened. New computer, so I got to figure out how to use it. Nope. Come on. There we go. I think that works. So let me rehash that. Since our p of x was degree 3, our answer will be 1 degree less. It'll be degree 2. All right, here comes the fun part. 5 times 3 is 15. Negative 12 plus 15 is positive 3. 5 times 3 is 15. Negative 9 plus 15 is going to be 6. And then finally, 5 times 6 is going to be 30. And 1 plus 30 is 31. So our quotient and remainder is 3x to the second plus 3x plus 6 plus 31 over x minus 5. Okay? Now, if they wanted you to write it out in the division algorithm format, you would have to write 3x to the third minus 12x to the second minus, minus 9x plus 1 is equal to our divisor out front, which would have been x minus 5 times 3x to the second plus 3x plus 6 plus 31. Okay? Let's do another one here. Okay, so our next problem is going to be x to the fourth minus 16 all over x plus 2. So before we can synthetically divide, we're going to have to rewrite x plus 2 as x minus a negative 2. Therefore, c is going to equal negative 2. Also, in the numerator, we have to fill in all those missing terms. So we just put zeros for them and just write them out respectively. Here we go. So now, when we go to set up our synthetic division, we put negative 2 in the box. Then we put a 1, 0, 0, 0, and negative 16. We drop down to 1, and then on the far right-hand side, if you want to, you can just write remainder. And now we just go through our process. I'm just going to go through it. Hopefully you can follow along by now. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. 0 plus 4 is 4. Negative 2 times 4 is negative 8. 0 plus negative 8 is negative 8. And then finally, negative 2 times negative 8 is positive 16. And negative 16 plus 16 is a remainder of 0. So this was the degree of 4 when we started, which means our solution, or our quotient, is a degree of 3. So this will be x to the third minus 2x squared plus 4x minus 8 for our final answer. If you wanted to write this out in the division algorithm format, x to the fourth minus 16 is going to equal the quantity x plus 2 times x to the third minus 2x squared plus 4x minus 8, and there is no remainder. And what's really nice is you can always check yourself. If you were just to distribute and multiply and then gather all your like terms, the quantity x plus 2 times the quantity x to the third minus 2x squared plus 4x minus 8 will be x to the fourth minus 16. All right, so what does this all mean? Like, we know how to synthetically divide. We know how to do long division. I would definitely lean on the side of synthetic division if your problem fits it, which I'm going to be honest with you, all the problems are going to fit it because that's what we're doing right now. But what does this all mean? Well, the last thing we're going to talk about is called the remainder theorem. Okay? Now, the remainder theorem states that if the polynomial p of x is divided by x minus c, then the remainder is the value p of c. Okay? So let me show you what this is talking about. I'm going to go back and use that original problem that we looked at. All right, so here it is right here. It's going to be 2x squared minus 5x minus 7 divided by x minus 2. Okay? Now, when we went ahead and we did synthetic division here, so just let me do it again real quick. Here we go. There's our setup. 2 times 2 is 4. That's going to be negative 1. 2 times 2 is negative 2. Oh, sorry, wrote that wrong. Negative 7 plus negative 2 is going to be negative 9. Okay? What the remainder theorem is saying is, if you have a polynomial p of x, so let me use my highlighter here. Here's p of x. Okay. So we got a polynomial p of x. And it is divided by x minus c. Well, that's definitely a thing here. Then the remainder is going to be the value of p of c. So ideally, the remainder should be negative 9. So watch what happens here. I'm going to take my polynomial, 2x squared minus 5x minus 7. I'm going to label it p of x because that's what it is. I'm going to evaluate p of 2. Now, where did I get the 2 from? Well, isn't that what c equals? C equals 2. So watch what happens. P of 2 is going to equal 2 times the variable squared minus 5 times the variable minus 7. So I substitute in 2. And notice I get 2 to the second is 4. 4 times 2 is 8 minus 10 minus 7. 8 minus 10 is negative 2. And negative 2 minus 7 is negative 9. Which is exactly what the remainder is. See, what we're doing here is we're using this form of synthetic division to recognize what C is, and we know C is an x-intercept. Okay? We also know x minus C is a factor. We also know P of C has to equal 0. In order for it to be a factor, and in order for it to be an intercept, P of C has to equal 0. So what I can say is, given x minus 2, let me write it down. Is x minus 2 a factor of 2x to the second minus 5x minus 7? In other words, what I'm asking is, if we were to factor 2x squared minus 5x minus 7, it would be a binomial. What I'm asking is one of these x minus 2? And what you can say, without even trying to factor it, what you can say is no. And the reason you can say that, because P of 2 equals negative 9. You, in the upper right-hand corner of your screen right now, you wanted to be P of C equals 0. So let me show you where this actually works, and hopefully it makes sense. Hopefully it starts to gel a little bit. We just looked at x to the 4th minus 16 divided by x plus 2, okay? So what we're going to ask is x plus 2 a factor to x to the 4th minus 16? Well, remember, in this case, C is going to be negative 2, because you got to rewrite it. You got to rewrite this as, I'm going to write it underneath here, x minus a negative 2. So what we're going to do is we're going to evaluate the polynomial using negative 2. Negative 2 to the 4th is positive 16, and positive 16 minus 16 is definitely 0. So I'm very happy because I can answer the question, is x plus 2 a factor of x to the 4th plus 16? The answer is absolutely it is. Why? Because when we take negative 2 and evaluate it into the polynomial, we get an output of 0. Now, the reason why I chose this problem, x to the 4th minus 16 is something that we should know how to factor by now. This factors down into x squared plus 4 and x squared minus 4. And if you notice, x squared minus 4 right here, that's a difference of squares, which means we can factor it even further. So you get x squared plus 4 times x plus 2 and x minus 2. And everyone, right here, is that x plus 2, and we ask the question, is x plus 2 a factor? Absolutely it is. So you can save yourself a lot of work by just being a little intuitive. You can ask yourself, okay, well, is negative 2 or is x plus 2 a factor? Use what we call the remainder theorem. So the goal of the remainder theorem, I'm going to write this nice and large. The goal of the remainder theorem is to find values of C such that P of C equals 0. If so, we can say x minus c is a factor to p of x. And that's what we're really looking at here. So let me do one more example here, okay? And then I'm going to show you how we can use the remainder theorem, and we can use synthetic division to completely factor higher order polynomials. All right, so here's our next problem. We're going to let p of x equal x to the third minus 7x plus 6. And what we want to do is show that p of 1 equals 0 is a factor, and use this to completely factor p of x. So what we're going to be doing here is we're going to be using a remainder theorem and this idea of synthetic division to completely factor p of x. Now, if you look at p of x, x to the third minus 7x plus 6, there is no technique that you are aware of that can factor that. I mean, really think about it. There's no GCF. It's a trinomial, right? But the leading coefficient or the leading term is x to the third, not x to the second. And that is what you're used to. You're really used to x to the second. But this, there's no simple algebraic formula that we can follow to factor this. However, we're going to factor this. So here's what we do. First, let's just show that p of 1 equals 0. Now, all they're asking us to do there is literally substitute in 1 for x and verify that when you go ahead and you simplify this, you should get, and we get, exactly 0. So what does that mean? Well, this means x minus 1 is a factor. So I already know one of the factors. I need to find the other ones. How do we find those other ones? Well, let's just use synthetic division here. So remember, we're missing a term. So I'm just going to write x to the third plus 0x squared minus 7x plus 6. So this is going to give me 1, 0, negative 7, 6. Now, we could drop down to 1. In this box on the far right-hand side, you can write the word remainder. And I can already put a 0 in there. I know it's going to be 0, and that's because the remainder theorem showed us that p of 1 equaled 0. So watch what happens here. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1 again. Negative 7 plus 1 is negative 6. And 1 times negative 6 is negative 6. And then finally, 6 plus negative 6 is 0. Excuse me. And here's the beautiful part about this, and this is why I get so excited when I teach this, because it is so much fun. We started off with p of x as a degree of 3. After one round of synthetic division, we have a degree of 2. Therefore, this polynomial is x to the second plus x minus 6. That is a quadratic that we can easily factor because it's in the form x to the second plus x minus 6, which means this will factor down into x plus 3 times x minus 2. Therefore, and I'm going to zoom out here real quick. Let me get a better marker. Therefore, p of x equals x to the third minus 7x plus 6 factored is p of x equals, you got your first factor, which is x minus 1. And then, using only one round of synthetic division, and I'll put them in order, x minus 2 times x plus 3. And that is how you factor it. So, you now have a very powerful technique on basically factoring anything. And when you think about that, that's unbelievably amazing. That we can take the remainder theorem and then synthetic division, and we can now factor problems which initially on a test you would write cannot be factored. Now I'm going to write, yes, it can. You got to figure it out. And how do we do that? Remainder theorem and then synthetic division. So in the next section, next week, I'm going to show you how to find C, because I've been giving it to you this whole time. But I'm going to show you a couple techniques on actually how to find that number. And then what we can do is we can really get involved and really explore other types of polynomials. Polynomials that have real roots or complex roots and all this other stuff that we can actually do. Okay? So if you have any questions, just let me know. But if not, I will definitely see you in the next video, which will be next week. See you later. Bye.